Assalamualaikum and good day everyone. So welcome to the very first recorded video for materials engineering, and today I am going to give the lecture on the topic 2, which is on the atomic structure and bonding. Okay, basically last week we had the first live lecture on the topic of materials engineering, which is on the introduction part, right? So for this video lecture, I'm going to discuss on atomic structure and also bonding, which some of you might be already familiar with the topic because you already learned this during secondary school or during matriculation, right? You know the differences between atoms, what are atoms, and then atoms consist of neutron, consist of proton and also electron, okay? And so this one will be the summary of what you have already learned, plus some basic calculation, and I think this one will be easier for you to understand. So specifically, the topic that I am going to discuss is on the types and of atomic and molecular bond. Okay, so we have atomic bond and molecular bond. So students should be able to describe these two different types of bond. Okay, so for types of atomic bond, we have ionic, covalent, and metallic. Actually, this belongs to the primary bonds, and for students are also should be able to describe type of molecular bond, focusing on permanent dipole and fluctuating dipole, and this should be the secondary bonds. Okay, types of molecular bonds is under the topic of secondary bonds. Okay, so other topic that we will learn is on the atomic structure and how these periodic variations and trends in periodic tables looks like in terms of electronegativity and so on and so forth. Okay, and finally the topic which is quite important is student must be able to explain the correlations between the structure and also bonding of atoms towards the material property. Okay, so maybe I can give you one example. For instance, if you know about polyethylene terephthalate. So this is the material which is used to produce water bottle. Okay, as you see, water bottle has transparency property. Okay, it is transparent. It can be see-through, right? So this is because it depends on the structure of these PET bottles. Okay. So PET can also exist in non-transparent property. It can also show non-transparent property because the structure is different. So arrangement of this structure give the transparent or non-transparent property of PET. So that's why it is important that students understand how this structure reflects or influence the material property. Okay, so I hope that students already have an overview of what they should expect for this subject or for this subtopic. And now let us start this video lecture. So here I want to give some definition. So the first one is on the atomic number, which is given as Z. Atomic number is actually the number of protons in the nucleus of an atom. Okay, so atomic number is Z. And then we also have the mass number, which is A. So what is mass number? Mass number is summation of protons and also not only proton but also including neutrons in the nucleus of an atom. Okay, so we have atomic number Z and mass number A. So if I show you this, one of the element in the periodic table, which is nitrogen. So from here, could you please tell me which one is atomic number and which one is the mass number? Okay, so of course the smaller number should be the atomic number and the larger number should be the mass number because the larger number represents the total number of proton and also neutrons. So here the mass number is 14. Okay, so it is at the bottom of the this element, and also the atomic number is Z is 7 for nitrogen in this case. Okay, it is usually on the top. Okay, if you look from the periodic table, you will see that the atomic number, which is the Z value, is at the top, and the mass number A is at the bottom. Then we also have the definition of atomic mass. So it is actually the mass of an atom, and the unit is AMU, atomic mass unit. And for carbon, we have 12, okay, because it is actually how you can calculate is 1 AMU equals to 1 divided by 12 mass of 12C carbon. So that's why it is we have the relative measurement of one atom with respect to carbon C atom. So this is how the atomic mass is defined. Then we have isotopes. Isotopes are element that has or atom that have same value of Z but different value of A. Okay, so I also give you in the activity list for you to write down elements that you know that have different isotopes, and then write down what are those Z and A value for those isotopes. Okay, then the next one is each 1 mole or 1 gram mole of an element contain 6.023 times 10 to the power of 23 atoms. So let's say I talk about 1 mole of carbon. So 1 mole of carbon has 6.023 times 10 to the power of 23 atoms. So as shown here, okay, 1 mole of carbon, you have 6.023 times 10 to the power of 23. So what about 1 mole of nitrogen? So actually it is also the same. We also have the same amount of carbon. We have the same amount of atoms, which is 6.023 times 10 to the power of 4. Okay, maybe I can write it down here. Okay, so 1 mole of element nitrogen will give you 6.023 times 10 to the power of 23 atoms of nitrogen. So it is similar like 1 mole of carbon. But of course, the atomic weight will be not the same because it depends on the mass number. So the atomic weight for nitrogen, it is not 12 gram like carbon here. Okay, carbon you have 12 gram, but for nitrogen we have 14 grams. Okay, so 14 grams of nitrogen for 1 mole of nitrogen element. Okay, so 14 gram and because it depends on the mass number. Okay, now I would like to ask you whether sometimes you see 1 mole and sometimes you see 1 gram mole. Is it equivalent? Of course, it is equivalent because sometimes in some textbook they use 1 gram mole and some textbook use 1 mole. Okay, so it should be equivalent. Similarly, if you have 1 kilomole or 1 kilogram mole, are those equivalent? Of course, 1 kilogram mole and also 1 kilomole, they are also equivalent. So maybe I can write the summary for this, the one that I have mentioned. 1 mole equals to 1 gram mole, or 1 kilomole equals to 1 kilogram mole. Okay, so because later on you'll find this, and please do not confuse yourself. Okay, then atomic weight is, or molar mass is mass in gram of 1 mole of element. Okay, the one that I've mentioned. So for carbon, 1 mole of carbon give you 12 gram of carbon, and 1 mole of nitrogen give you 14 gram of nitrogen. Okay, so I hope that it is clear for you on the characteristics of atom. And let us now discuss on electronic structure of an atoms. What is electronic configuration? It is actually the list of arrangement of electrons in orbital. Okay, so maybe I can introduce you some definition. For instance, shell number, which is usually given in N. Okay, it is actually the also called principal quantum number. Okay, so let's say n equals to 1, equals to 2, or equals to 3, there is a principle, so-called Pauli principle. So if the principle is 2n squared, okay, the principle is 2n squared, that means if the shell number, which is 1, okay, if the shell number is 1, then 1 squared, okay, is equals to 2, okay, and if we have 2 shell, then we replace n here with 2, then 2 squared is 4, multiply with 2, that gives you the answer 8. Okay, each shell has subshell. Okay, for 1 shell number, we can have only 1 subshell, which is S. Okay, for 2 shell number, we can have 2 subshell, which is subshell S and also subshell P. Okay, and if we have 3 shell number, we can have 3 subshell, which is S, P, and also D. Okay, so if you apply 3 shell number, which is N, so N is 3, and 3 squared is 9, and 9 multiplied with 2, you get 18. Actually, this table is truncated. You can look up in the textbook because you can have a larger shell number, okay, for different atoms. So in order to explain you on this arrangement of electrons in orbital, so I would like to give an example using magnesium. So magnesium has the atomic number of 12. Okay, the atomic number, please remember atomic is Z, okay, and mass number is A value. Okay, so mass number is usually larger than the atomic number. So for magnesium, you have atomic number of 12 and the mass number of 24. Okay, so for instance, I am talking about magnesium, which has the atomic number of 12. So how can we arrange, okay, because it is about the arrangement of electrons, right? How can we arrange the electron in the orbital of for magnesium? Okay, so as you know, the bigger the atomic number, so we have different arrangement. We have longer arrangement, so that means we have because the arrangement depends on the subshell, right? So with increasing atomic number, the subshell will also increase, then the size of the atom will also increase. So for 12 here, so we have 12 altogether for the atomic number of magnesium. So how can we know that our arrangement is correct? So if we want to calculate the number of electron, so the number of electron is given in this superscript number in green. Okay, so if we add up all this together, 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 2 is 12. So this is the total number of electrons that presents in the neutral magnesium. Okay, that means without charge. Okay, so then we have orbital numbers, which is given in the blue letters here, S and also P. Okay, as I mentioned, since we have only okay, it is not full, right? So the S2, it is not full. The third shell is not full. We only have up till S here. So if we have full valence, okay, then we should have P6 and also D10 for shell number 3. So for in this case, we have only 2 because the electrons for magnesium is only 12. Okay, the remaining 10 electrons fill the first and second shell number. So that means for the first shell number, we have shell number 1. And as I said, for first shell, we can only have one subshell, which is subshell S. Okay. So, and the number of electron that can fill, the maximum number of electron that can fill for first subshell is 2. Okay. Then we have another 8. Okay, because the first and second subshell are fully filled with the electron. So the second shell, we can have 2 subshell, which is subshell S and also subshell P. So this is also maximum. 2 plus 6 is 8. Okay, so that's why first and second subshells are completely filled with the electron in the valence. So in the orbital. So that's why we have altogether 10. Then we are remaining with 2 electrons in the valence for the third subshell. So that's why we only have S2. So if we write down the arrangement of electrons in magnesium, so it should be 1s2, okay, 1s2 and 1s2, 2s2, 2p6, okay, according to this table, and also 3s2 because we have only up to 12 electrons. Okay, so the core charge here, if magnesium give up or lost 2 electrons, so we are it will be only 10 electron remaining. So that's why we have positive 2. That's why magnesium we have charge positive 2. Okay, so this is for magnesium. Please look up for calcium and also for potassium. Okay, please look up how can one write the electron configuration for calcium and also for potassium. Okay, and maybe I will put some other element in the e-learning so that you can write the electron configurations for those elements. Okay, maybe you are wondering why I ask you to choose calcium and write the electronic configuration for calcium. Okay, clearly it is because when you write this down, you will see that the valence electron, the electrons in the valence shell for calcium will also be 2. Okay, so from there, that's why calcium, it has when it give up electron, when it lose electron, it will also become positively charged with the value of +2. Okay, so for calcium. So that means here, because calcium is also same group with magnesium, which is group 2. Okay, all the element in group 2 will are going to have charge positive 2. Okay. And then just to compare, I also ask you to write down on potassium, the electronic configuration for potassium. So basically you can already expect that potassium, you are going to have 1 electron in the valence shell because it is on the, because potassium is from the element from group 1. Okay, so that's why you can expect this already. Okay, so group 1 and group 2 are the element that can easily lost its electron. So which I'm going to explain why and the reason in the next video lecture. Thank you.